Good morning, everyone. I want to welcome you to the third plenary address for ISSRM 2012. I'm delighted with the turnout because you often find on the last day of the conference that people don't turn out as much. But I think that speaks to really the deep respect that so many people have for the knowledge of Dr. Schindler. So it's a real treat for me to introduce to you today Dr. David Schindler. He is talking to you today about the scientist as advocate, a theme that has run through all of our plenary speakers. In fact, like Aaron Freeland Ballantyne, Schindler received his doctorate at Oxford University, where he was also a Rhodes Scholar. He began his career as an assistant professor at Trent University in Ontario. He then joined the Fisheries Research Board of Canada, where he was the founding director of the Experimental Lakes Area, otherwise referred to as ELA. This is in northwestern Ontario, a facility where the impacts of pollutants can be studied in whole ecosystems. It's a rather sad situation now where our federal government is threatening to no longer fund the ELA, and Dave has been highly occupied in the last few weeks trying to defend the ELA and bring our government to its senses. Schindler's work with eutrophication and acid rain has been used in Canada, the US, and in Europe as a basis for changing environmental policy. He left the ELA to take the University of Alberta's Killam Memorial Chair as professor in ecology in 1989. He's the author of over 300 scientific publications, and Dr. Schindler has chaired numerous international and federal commissions, expert panels, and review commissions. I could spend another 5 to 10 minutes listing all the names of the international awards Dr. Schindler has received. It is really impressive. But just a few of them include the International Society of Conservation Biology's Laureau Prize, Canada's highest scientific honor, called the National Science and Engineering Research Council's Gerhard Herzberg Gold Medal for Science and Engineering. He's received the Killam Prize for Natural Sciences and the Royal Canadian Institute's Sanford Fleming Medal for Public Communication of Science. And just recently, the Canadian Society for Ecology and Evolution's President's Award. So in addition to, dozens of awards, Schindler has also been awarded 11 honorary doctorates in Canadian and US universities. He is also a fellow in several royal societies in nations with outstanding scientific productivity. In fact, he has been named as one of the 50 most influential Albertans for 3 years, most recently in 2011. His current research includes the restoration of mountain lakes stocked with alien fish species, the restoration of eutrophic lakes, and the effects of the oil sands industry on the Athabasca River. So before I turn the podium over to Dr. Schindler, I want to tell you a bit about his outstanding success record in using his scientific knowledge, communication skills, and his willingness to work with various stakeholders, such as First Nations, to influence environmental policy. Dr. Schindler chairs the board of directors for the Safe Drinking Water Foundation, a small nonprofit foundation that specializes in helping Aboriginal communities with their water problems and in educating students about protecting fresh waters. Dr. Schindler has testified in several hearings on eutrophication, using results from that Whole Lakes experiment place to advocate for control on phosphorus inputs. This work is the main reason why we don't have phosphorus-based detergents anymore, and why phosphorus is removed from most large sewage treatment plants in the first world. Again, using these whole lake results, advocating for more stringent controls on acidifying emissions, these results are the main reason why we try to keep lakes at a pH 6 and higher rather than pH 5, which was originally believed to be safe. As a member of the Federal Provincial Review Panel on the Alberta Pacific Pulp Mill, Dr. Schindler convinced the panel to recommend against the mill because of dioxin releases. This led directly to the Northern River Basin study, which resulted in all Alberta pulp mills changing their processes to produce no dioxins. As a result, we no longer have consumption advisories for fish caused by dioxin in Alberta rivers. Dr. Schindler also instigated a study of mercury in Lake Wabamun, showing that amounts in sediment increased every time a new power plant was added. As a result, for the last power plant, there are restrictions on mercury emissions, causing overall emissions to be 1/3 lower than they were before. And finally, most recently, Schindler and colleagues' studies on the Athabasca River near the oil sands triggered a thorough re-examination of the monitoring program for the Athabasca River by the federal and provincial expert panels and the Auditor General's office. Monitoring is being improved, and he continues to push for the resulting program to be thorough and publicly transparent. I've had the pleasure of teaching an interdisciplinary course with Dr. Schindler for 5 years, and I can tell you he is also a wonderful teacher, and he is very interested in the work of those who study society and natural resources. Please join me in welcoming Dr. Schindler.
Thank you, Naomi, and thank you all for turning up to hear me on the last day of a conference. I know how wearing they can be after 4 days. What I'm going to do is to talk to the exact title that Naomi proposed to me when the planning for this conference started some years ago. I think to start off with, it's worth pondering a little bit what advocate really means. There seem to be different definitions in different people's heads. For example, if you look at the best climate website there is, realclimate.org, they define an advocate as somebody who takes a position and then tries to twist all of the science to fit it. Probably biased by their view of what's happened to climate scientists over the years. I prefer Webster's definition in that someone who defends a position. And I view myself as someone who uses science to defend a position. My expertise is, you might say, the globe's freshwater plumbing. And when I think of disasters that have happened on past houses that I've built, I wouldn't want policy made on the world's plumbing where the plumbers were excluded and politicians and priests made all of the decisions. So I think people with a specialty should be morally obligated to share their expertise with politicians, even when it's unwelcome, when policy is being made. Let's see. If you look at a list of eminent scientists, and I made this up in about 5 minutes, I think there are a lot of people who share my view. This top list, most of you know who James Hansen is, written the book Storms of My Grandchildren, is a world-renowned expert on climate in the U.S. Wally Broecker is the foremost oceanographer of the 20th century, discovered that the oceans were not going to absorb all of the CO2 we were emitting. He wrote his first paper on the topic in 1957. Both of them are, and Gene Likens here at the bottom, famous because of his work at Hubbard Brook, are Blue Planet Medal winners. The other three you'll probably recognize because they're all Nobel Prize winners. They're the only three environmental scientists who've had enough overlap with fields where Nobels are given to be given a Nobel Prize. And in all three cases, it was for atmospheric chemistry. We've also had some very high-profile advocates in Canada. Digby McLaren was president of the Royal Society, also a member of the Royal Society in the UK. Ken Hare was president of the University of Toronto, also a member of the Royal Society. John Small has received the Gerhard Hertzberg Medal 2 years ago. very well-known freshwater scientists, and Andrew Weaver, who's written a book on climate and is a fellow of the Royal Society of Canada, is also a member of the Royal Society. So if this is unbecoming to a scientist, I share that position with some pretty eminent people. Well, going back, I would say that it's an advocate that got me interested in natural sciences in the first place. I was an undergraduate in engineering physics, and one summer I happened to get a job working for a biologist who wanted a common instrument in physics in those days, a bomb calorimeter, where you exploded materials in an oxygen atmosphere and measured their energy content. He wanted to do that to freshwater organisms. It was a freshman lab in physics, and he hired me to do it, even though I was from a different university. And I borrowed things to read that summer, and this book I've given at the bottom here, Charles Elton's Ecology of Invasions, written in 1958, just blew me away. It made me change fields and universities and do my PhD with Elton some years later. And this quote in the middle is one that I will never forget. I hadn't realized what we were doing to the biodiversity of the planet as a 19-year-old student. So there was advocacy, though of a more gentle sort, going on even a half-century ago. But along the way, I started to realize all of these people sitting in their ivory towers are putting all of this work into producing papers that go in ivory tower libraries. And when you look back after 10 years, most of them have been read by less than 100 people. What a waste, even for the ones that have relevance to policy. And this is just not the way I've wanted to operate, nor do I think it's the way the general public wants to operate. Most of my relatives are non-academics. Most of them were always very curious about what I did and what they were getting for the money they put into universities via taxes. It was rumored that I had this cushy job where I got paid to go fishing. So I got used to explaining what I did to lay people, and I've always had a life outside the ivory tower, so that's remained a fairly easy thing to do. Well, the first problem that attracted me when I moved to Canada was the state of the Great Lakes. This is Lake Erie as it looked in the late 60s and early 70s. And it was of enough concern that there were two new big science organizations being formed in Canada to study it. One was the Freshwater Institute in Winnipeg, which had a whole section, about a third of the group, focused on this problem and trying to figure out what caused it and how to solve it. And the other was the Canada Centre for Inland Waters in Burlington, Ontario, which was devoted directly to study of the Great Lakes. I was encouraged to go to an international symposium on this topic, which resulted in this book in 1969, 2 years after the symposium. And it was a puzzling symposium. There's not a single recommendation in this on how to control the problem. And there are papers in there which make a case that almost every element on the periodic table needed to be controlled to control the problem. Well, at that meeting, I met Jack Valentine, later known as Johnny Biosphere, who had just been appointed the leader of the eutrophication section at the Freshwater Institute. And he recruited me specifically to undertake a whole ecosystem study of this problem. I was first asked to select an area for lakes, which I did, just here in Western Ontario. This shows some of them that were the sites of some of the better known experiments, and then get a road built to the lakes and put in a camp where these lakes could be studied and year-round permanent science could be done. So all that was rather fun. It was more of an adventure than real science, but for a 27-year-old, this was great news, a lot better than sitting around in an office and sipping sherry afterward. Well, the case had already been made to the International Joint Commission on the Great Lakes that phosphorus should be the element that should be controlled. That was made by groups of scientists based on small-scale experiments in the laboratory, largely with algal cultures and little bottles of lake water. But the detergent industry in particular didn't like that idea because their detergents were based largely on phosphates. So they found 3 people who had experiments that suggested that phosphorus was not the problem, that it was carbon, and made the case that all of these people backing phosphorus were wrong, and the International Joint Commission was on the verge of making a wrong decision. This whole business smacks of exactly the same sort of propaganda that we hear all the time on climate and oil sands and everything else. And I think one public lesson that needs to be learned, and one that advocates need to learn to stress if they're scientists, is when people tell you something, don't just accept it. There are things that we have that are not TV commercials, and I think modern politicians think they're producing TV commercials where honesty is not expected. But this was the focus of our first experiments at ELA. Here was another piece of propaganda that they disseminated. There had been a paper published by Tom Edmondson, a limnologist at the University of Washington. A limnologist is a freshwater equivalent of an oceanographer, that showed what had happened to the lake after they reduced phosphates. He persuaded the city of Seattle that they were putting too much phosphorus from the exploding development in the city into Lake Washington, which is right in the middle of the city. And as a result, they diverted the sewage from Lake Washington and flowed it into Puget Sound. And Edmondson tracked the decline in phosphorus and the resulting decline in chlorophyll. Well, the clever soap and detergent people reinterpreted that. In their version, the decline in chlorophyll produced the decline in phosphorus. The logic of that is analogous to claiming that lung cancer produces cigarettes, but of course that's way too subtle for politicians, so it delayed legislation. Well, in our survey work in 1968, one of the lakes we surveyed was this little 5-hectare lake, which we called and still call Lake 227. It had the lowest carbon content of any lake that had been studied anywhere. We had to devise new methods to be able to measure it. So we thought it'd be interesting to add phosphorus and nitrogen to this lake. If we can make it eutrophic, which we did by doing that within weeks, it would knock the carbon theory that you needed to control carbon, which the detergent companies were pushing, right off the stage, and that's what happened. In some subsequent science, we were able to explain how that happened. The small bottles that they'd been relying on forgot some of the natural biogeochemical cycles. For example, a little bottle with a stopper in it doesn't get any carbon input from the atmosphere. And yet lakes have a big atmospheric carbon exchange. When you add phosphorus and nitrogen, the partial pressure of carbon dioxide in the lakes drops way down. This is in orders of magnitude. And as a result, there's a big carbon invasion to the lake, which over time solves that carbon shortage problem. Well, the detergent company quickly gave up on that idea, but their next story was, well, you could never control phosphorus well enough, that it was recycled so quickly that you'd have to control something else. So we tested that one too by curtaining this lake in half and then adding nitrogen and carbon in amounts analogous to what would be entering from sewage effluents to both sides of the lake, but phosphorus only to that one. And you can see what happened in this slide, which was only taken a few weeks after we started. This picture has been reproduced in almost every university textbook since that day, and it's been reproduced 3 times in Science alone as examples of various things about the impact that science can have. This is a recent quote from Jim Elser, who's a limnologist at the University of Arizona, who's worked at ELA in the past and uses it all the time in his classes. This has another message. If you're an advocate, the old adage that a picture's worth 1,000 words is probably an underestimate. It's probably worth 10,000. The most scientifically illiterate of legislators can understand what's happening in this slide, even though he may not understand all of the technical graphs and things that go with it. Well, we were very proud of what we did in those days. In 1974, there was an International Limnology Congress held in Winnipeg, which had 1,200 attendees. I was asked to give this in a plenary talk. There was a unanimous declaration by the Congress that phosphorus was the key to controlling eutrophication. So in less than 4 years, we'd moved from pilot research to having a solution for this problem. Now, this was all put to the IJC, not by me. I was off having fun in the bush, but by Jack Valentine, my boss. But at that point, there was a disaster happened, and there was a second phase. The US had done nothing at that point. Canada capitulated almost immediately and banned phosphate detergents and put in phosphorus control on sewage effluents. The US was just forming the EPA, and they decided that EPA was still too weak to undertake such a thing, so the federal government left it to individual states whether they wanted to ban phosphorus or not. Took 17 years to get that done, and Valentine didn't do it because at that point the Fisheries Research Board of Canada, which was independent of the civil service, was disbanded. There was a lot of jealousy that developed because of the FRBC's high profile, and Fisheries and Oceans and Environment, newly formed civil service departments, convinced the politicians that they should roll it into those 2 organizations. That was the start of the decline of science and environmental policy that we see at rock bottom today. Valentine left. Before he left, he hauled me into his office and said, this is not going to help the Great Lakes if just Canada bans phosphorus. The US has to be convinced, and that you have to do it. Nobody else is going to do it. So that was the start of my career in science advocacy. I went to state hearing after state hearing, typically following a traveling circus, which usually had on the order of 50 to 70 presenters sponsored by the detergent agencies, all the way from scientists to housewives who would swear that non-phosphate detergents would destroy their washing machines. And that's where I've got involved in this kind of thing. And I won't go into that case anymore because it's written up in this little book, which you can get at the University of Alberta Press. So the next case was acid rain. Remember, we were now civil service, and the bureaucrats started referring to ELA as a sunset program. And I said, well, what does the sunset program mean? Oh, well, you're slated to be shut down because you've solved the phosphorus problem, and that's what you were created for. Therefore, we're going to take the money and use it for other things. So by that time, I was convinced that we needed a whole ecosystem approach and other aquatic problems, and started studying problems, and one that came to mind was acid rain. Scandinavia and the United States had already discovered that acid rain was a big problem. Canada had more acid-sensitive terrain, shown in orange, than the US did by far, and you can see by these isoplests that the center of the acid rain bullseye extends well into Canada. That's because the prevailing wind direction is from the southwest, carrying the sulfur oxide emissions which produce sulfuric acid from the Ohio Valley and other industrial areas. Well, I made this presentation along with some preliminary evidence that pH was declining in lakes to DFO's senior management. They'd already started the transition from being scientists to being MBAs, and one of the middle managers stood up and accused me of inventing the problem to solve ELA and keep ELA alive. And needless to say, they didn't allocate any money. Luckily, the Alberta oil sands were starting up, and they bought the idea that they needed to look into this. They knew they were going to be putting out lots of sulfur emissions. The head of the monitoring program at that time was a colleague within the Fisheries Research Board of Canada, who also ended up leaving. But they bought the idea that because we had the background data and we had more or less the same fauna and flora that they were concerned about, that we could do an experiment that would be useful to them. So what we did was to acidify this little lake, Lake 223, the smallest lake in the area that had lake trout in it. And we found that at pH 6, 1 pH unit, or 10 times less acidic than had been thought, again based on small-scale experiments of the day, as to where damage to lakes started. This is the opossum shrimp. It's a glacial relic that co-evolved with lake trout and other cold water species. Turns out that it's a primary food for small lake trout. And this was the other important food fish for lake trout in the lake, the fathead minnow, and it quit reproducing at pH 6 and went into decline too. Both of them were extirpated from the lake. As a result, lake trout, which looked like this at the start of the experiment, a few years later looked like this, not because they were affected by acid toxicity, that wouldn't have set in till pH 5, but because they were starving, because their food organisms had been affected. And as a result of starving, they quit reproducing, so they too went into decline. Nothing to do with direct toxicity at all. And over that same period, we recorded the species losses in all of the groups of organisms where we had expertise in taxonomy. And we found that the overall diversity in this pH range, which was originally thought not to have any impact on lakes, actually caused a loss of 1/3 of the biodiversity in the lake. So again, I went around to hearings all over the place. The target audience here turned out to be a different one in Canada. The government was made of all of these MBAs who started to procrastinate and make excuses, but industry got it. And here you can see the result. This line has been the control orders imposed by the Ministry of Environment for Ontario. And you can see industry, the bars, has consistently run ahead of them on what they've done with their emissions. So people are asking me all the time, what's the best target? Well, you have to deduce the best target as you go. In the eutrophication case, it had been the government itself because they listened to these eminent fisheries people who ran the Fisheries Research Board. In this case, most of the sulfur emissions in Canada were put out by 7 or 8 sources. And the CEOs that controlled those sources could see the handwriting on the wall. So much as government tried to keep up and pretend to get to the front and be leading, industry really led this example. And the result has been that the US followed later, and that was a government action. It took several years to convince them to regulate, but they finally did. And as a result, you can see some of the heaviest atmospheric deposition has gone away in this 10-year period, thanks to the decline in science in Canada. This figure from Environment Canada has not been updated recently. So at that point, I was getting rather fed up with dealing with a bunch of dead-headed bureaucrats, and that and a few other reasons made the move to Alberta. And the first thing that happened, I was given a term with no teaching, and for that term, I was invited to be a federal member of a federal environmental review panel. Actually, the first one in Alberta was surrounding the Alberta Pacific pulp mill that was proposed for the Athabasca River. There were a bunch of environmental groups and retired scientists who were concerned about the mill. And this panel, I found myself the only environmental scientist on it. Many of the other people stood to make money from the Alberta pulp mill. There was the owner of an airline based in Athabasca, the chairman of the local school board, a couple of business people, etc. But rather than just going around and listening to people, I convinced this panel that we needed to hear something about the dioxin output that was proposed for this. The calculations that I did on the back of an envelope indicated that the dioxin output in that relatively small river would result in concentrations that were just as high as in the Fraser River with several big pulp mills, which was sterilizing bird colonies in the Fraser River Delta. So we got several federal scientists to come and testify, and the result of that was that the panel, even the people who were personal friends of the Premier and Minister of Environment, recommended against the mill. And of course they built the mill anyhow, but they did a nice political dance that resulted in the Northern River Basin study to study dioxin. They also imposed some more stringent standards on the mill, and the net result 20 years later is that we no longer have mills in Alberta that put out dioxin. I got a lot of blame for what went on at the time. It's rumored that the Department of Environment actually visited the president here to see about getting me fired, but luckily I had tenure. But by 10 years later, when he retired, the first CEO of the Alpac plant thanked me for my influence because it elevated them to the first mill anywhere that had not produced dioxins. Following that, I had a group studying organochlorine pesticide deposition in the Rocky Mountains. And just at that time, it happened that the Swan Hills waste incinerator, northwest of here, was discovered to have a leaky stack. Rather than being totally combusted, dioxins and furans and PCBs and things had been emitted from the stack and sprayed over a wide area. Nobody knew how far for some time. Well, we had the methods. They were the same as we used for organochlorines. In fact, we also did PCBs in the mountains. And I had a young, enthusiastic postdoc and knew another young scientist in public health, lined them up with a trapper I knew in the area who took them around, and they sampled the snowpack for a 20-kilometer radius around the plant, including Christina Lake. And you can see what happened. There are two 1997 bars here. This was the concentration of PCBs in sediments before this leak was discovered, and this after. Indicated it probably had not been going on for years. It was probably a few months. But we also discovered that fish in that lake had PCB concentrations that should result in a consumption advisory. Our data for snow indicated that the plant had contaminated snow to a pretty high level for a 20-kilometer radius, and as a result, consumption advisories were put on eating either fish or game caught within 20 kilometers of the Swan Hills plant. And unfortunately, those consumption advisories are still in place today, whereas the ones for the Athabasca and other river systems slowly declined after the pulp mills stopped producing dioxins. Until today, I think there's just one small stretch left that advises against eating burbot livers, and other than that, fish are consumption advisory free, at least for dioxins and related compounds. And I've been involved in several other skirmishes. I had done a review of Lake Wabamun. Bill Donahue, then a postdoc with me, and I took some lake cores and did mercury analyses in the cores that showed that every time there was a power plant added, mercury went up in lake sediments and probably also therefore in the lake. Bill did the advocacy on that one, presenting it to the panel considering a new power plant for Wabamun, and as a result they imposed restrictions on that power plant. Instead of 600 kilograms of mercury per year being spewed out over the landscape, there's now only 400. But we have another potential problem arising. The oil sands have gotten as high as 100, and of course they're supposed to double and then quadruple over the next period. So it's time we had the same restrictions there. I've also been involved with climate change deniers over the years as part of a big North American scientific group, and I've served on federal panels to consider both the Species at Risk Act and the Fisheries Act. Going to now come to the past decade. Going back to eutrophication, Lake Winnipeg has recently exploded with algal blooms. And much to my dismay, people had forgotten what went on at ELA, and there's a group of scientists back saying we need to control more than phosphorus. Well, I did some work on the lake in 1969, the first year that there were any modern studies done. This is Jack Valentine at the bottom, and a much younger me standing on board the Bradbury, a ship that's now in the Marine Museum in Gimli. But I had hired a young lady by the name of Hetty Kling, got her trained to do our phytoplankton work over the years, including Lake Winnipeg, and she's done the phytoplankton work for that entire period. The data show that the big increase in plankton over that time has all been in these nitrogen-fixing blue-green algae, represented as the light blue part of each of these bars. So this is pretty incontrovertible evidence. when those blue-greens increase, it indicates that nitrogen is actually in short supply relative to phosphorus. So in this situation, controlling nitrogen would probably worsen the problem and be a waste of money. For example, controlling only 5% of the phosphorus and nitrogen, that emanating from the city of Winnipeg, would cost $400 million, whereas phosphorus alone can be done for $100 million. Most of the problem is agricultural, and the focus should be on phosphorus. And this paper just came out last week, a model that we ran, showing that the phosphorus concentration in the lake, shown by the black line, and the measured values are the black triangles here, or spades, I guess you'd call them. The green are the algae, and the driver of that, as well as the nutrient concentration in the lake, is the Red River discharge. What's happened is in the last 15 years that has caused this explosive algal bloom is two things. Number one, there's been an increase in hog culture in that watershed to where Manitoba now raises 10 hogs a year for every human in the watershed. There's 30 million hogs produced in the Red River Basin in a given year. But coupled with that, there have been 5 floods in the last 15 years that would once have been called a 1-in-100-year flood. Seems to be driven by two things: a slight increase in precipitation and a continuous stripping of wetlands and a drainage of the watershed. So that combination is what's driven this explosive increase in algal blooms. So that is currently under consideration, and I've been involved with talking to mayors of Winnipeg and provincial officials about that in what I guess you would call an advocacy thing. And of course, I've been involved in the oil sands. This is an example of the sort of rosy things we hear about the oil sands. Alberta's, a couple of years ago, spent 25 times more on propaganda than they spent on environmental research. But they were surprised when they hosted a visit by National Geographic, which came out with an article that wasn't very kind. They referred to it as scraping bottom, and this was one of their main pictures. And the premier was quite surprised at the time by this, and recommended that they up their PR campaign. Well, my uncles and people who were rednecks in the town where I grew up used to call these sorts of people who do this sunshine boys. They're hired to blow sunshine into dark places. And most of them sold Edsols and things like that around the town, but the term fits for the oil sands pretty well. The oil sands has an even bigger list of environmental problems than it does advantages, and something that forces in this province are reluctant to admit. Of course, there's been a recent move to examine environmental groups and their budgets. It's claimed that they're sabotaging Canada and Alberta by making crazy claims. But I don't think they deserve any credit. Who listens to environmentalists? On the other hand, people do listen to former premiers, like Peter Lougheed, recently voted the best premier in Canada of all time, and he has not been a fan of the rate of development. And articles by well-known business journalists talking about carbon programs, and federal ministers who says that, like Jim Prentice, who says that Keystone shows need to improve its record. And of course, just a couple of days ago, they had yet another oil spill. And companies, Greenpeace could only dream of the sort of publicity that you get when a company like Syncrude, following 1,600 ducks dying in a tailings pond, kept those in the news every day for a year, with a lawyer making crazy claims like the ducks should have known better and things like that. If they had been smart, they would have paid their fine and silently sneaked out of the room and done something about the problem. But instead, they kept this in the public eye, and you'd see a picture like this one almost every time you picked up a newspaper. I think it's fair to say that that development in the oil sands has in recent years been at a rate that is absurd. It's faster than the rate of the Manhattan Project or of the Apollo project to put a man on the moon, and there's been 10 times more invested in it than either of those programs. Typical governments think 3% a year increase is great, and they can thrive on that. You wonder why it is that we're at 7.5% a year, which means a doubling in 10 years if you do the compound math, and we're still awash in red ink. Something's not right here. But all the time we're hearing things like this. This is from the Sunshine Boys. This was from an actual newspaper ad. Shell's oil sands mining operations are polluting the Athabasca River is a myth. In reality, the oil sands have been leaching naturally into the river for 10,000 years. Shell ensures its operations don't add a drop to that. In even more absurd claims, I couldn't find the quote, but one of the oil companies claimed they were actually cleaning up the oil sands by taking the bitumen away. They were ensuring that in the future there'd be less getting into the river. Well, that gives all the credit to a few little seeps like this, and it ignores things like atmospheric emissions, which I don't think can be ignored. Over 30 years ago, I chaired this panel for the U.S. National Academy, which put out a couple of 100-page report, and we did not find a single smelter or fossil fuel-fired facility that did not discharge pollutants to the atmosphere, nor any case where they did not fall back to the biosphere. So the oil sands claim, with two so-called upgraders burning coke and producing temperatures of 500 Celsius in their atmospheric effluents, it's like claiming an immaculate conception, I think, is about the only thing you could consider it as being. Didn't think it was too likely. On top of that, outside of its TV ads and so on, industry is admitting that it's all you have to do is Google on the first four letters here, NPRI, and this huge spread chart will pop up with all of your elements and all of your companies in Canada, and you can look for your favorite company and toxic element and see how much they put out over the years. Here are 3 graphs of things that are of concern. So these ads are nothing short of crazy, and they should be stopped for dishonest advertising. This is the provincial program. The yellow stars represent sites on the Athabasca River, and the four-sided stars represent their only sites on the tributaries. And of course, the tributaries are where all the mining action is at. So I don't know how from one site at the mouth of each tributary they can tell that industry's putting in nothing when they have both industry and natural sources upstream. On top of that, there was this review of the Regional Aquatic Monitoring Program in 2004. It was about 100 pages, and 99 of it trashed this program, indicating that it was worthless. That report was hidden until a couple of years ago, but a second review was held in January of 2011. They found that instead of fulfilling 0 of their 7 objectives, they'd fulfilled 1. That was to get themselves re-reviewed. So if you want to check for yourself, this is the URL for that second report, which this time at least is publicly available. I'd worked on watersheds for 40 years, and when someone tells me that you can strip the soil and vegetation off a watershed and that nothing happens to the chemical flow from that watershed into adjacent rivers, I say you're a liar. But this is exactly what they were telling the public. So 3 of us devised a detailed study where we got the GIS map of the Athabasca River. The white here is the bitumen-laden formation. We hired Erin Kelly, who had done her PhD with me a few years before as a postdoc to run the program. And all of these are sites that we sampled on the main stem Athabasca, plus 3 on each tributary upstream of the natural bitumen sources in the McMurray Formation with its natural bitumen, and then downstream of industry. We also sampled snow in late February at those sites, 31 of them at least, and you can see the tip-off. The snow for a good distance around that plant is gray, and you can see these episodic events in the snowpack. Well, when we melted the snow and filtered it, this is what the filters looked like. This is the upstream end at Fort McMurray going downstream to Fort Chip, and these are tributaries from upstream natural sources and then below industry. The yellow numbers are in kilometers, giving you an idea for an area with no roads of the difficulty of getting around and getting samples in this area. But after we filtered the snow, there was an oil film on the filtrate. You can see this stainless steel pot has a sample from right near the upgraders. This one is from a remote area. You can see the water is nice and clear. And this is a paper towel used to wipe out one of these contaminated pots. Well, to make a long story short, we found that there were big atmospheric inputs to the snow right near the upgraders. This is AR6, where the upgraders are right across the river from each other. It's spread for quite a distance around the plants, upstream and downstream. If you look at the snowpack within a 50-kilometer radius, it's represented by the gray bars here. These, this time, are toxic metals, whereas the white bars represent remote sites. And you can see that in almost every case, clear evidence of pollutants coming out of these stacks. We did an analogous thing for water in the river. Fort McMurray's at the bottom and going downstream in the Athabasca. You can see this, again, this bulge near the center of oil sands activity, tapering off somewhat, but not entirely as you go downstream. So pretty clear evidence that contaminants are being put into the river. And I could show you a lot more of these, but this isn't the point of my talk. So we wrote all of this up, published it. I wrote this article making the point that the reason that these things have been declared as undetectable is that the monitoring programs were inadequate, that they were in violation of the Fisheries Act, at least before Bill C-38 gutted it. These companies were basically violating the law. So the ministers denied that. Alberta Environment says that the increased toxins were natural. He admitted that he hadn't read the paper, which I sent him before release. The Environment Minister initially said the same thing. But then one day I got a phone call about 4 days after he'd said that, saying that he'd had advice that maybe he ought to look at our results from his scientists, and if he flew to Edmonton, would I meet him at the airport and show him our results and discuss them? So I did. And When I was done, he was convinced. It was pretty clear. And he said, well, what do I do? And I said, well, nobody's going to take the word of one scientist. Why don't you appoint a panel of other experts to look at our results? So he agreed to do that. A few days later, the provincial minister, under direction from the premier, did the same thing. And we had the first two of what turned out to be a total of 6 panels examining our results, resulting in all of these different reports. This one was independent of our stuff, but also examined them, the Royal Society one. Environment Canada, appointed by Prentice, the RAMP review panel, which was independent, this data review panel by the province, followed by this monitoring panel after all of these panels had said that we were right, the program for monitoring was inadequate. This last one was charged with designing a world-class monitoring program. And they told the two governments, you guys have lost your public license to run a monitoring program. Nobody will trust anything that you run because of your past performance. Therefore, it has to be independent. The Alberta minister said he'd act on it right away. So far, we've seen no action. We've had a change of premiers. We've had a change of ministers of environment. But the new Minister of Environment has appointed a subgroup from this AIMP panel to recommend what an independent group would look like. And it's no secret that they really don't like this idea of independence. As the previous minister said, I don't see a mechanism for allowing us to get rid of science we don't like. So it remains to be seen. They're going to be reporting on July 3rd. And I think a first test of this government will be to see if they act on the recommendations of this working group, as they call it now, or to shovel them under the rug. Perfect. Some of the things said by panels were pretty unkind about the past monitoring program, which had been touted by the minister as having 4 million data points. Didn't say for what or how accurate they were, but this is a choice quote. Minister had been touting this report. And as we had surmised from our polycyclic aromatics, their limits of detection were 100 to 1,000 times less sensitive than the ones we used. So the message for a CEO who wants to get around the rules is get the lousiest monitoring group and the lousiest chemical labs you can, and then it'll be least likely that they find anything you're putting into the river. And they had good things to say about our panel report. So as a result, we got this series of articles coming out. The last one demanding that the government apologize to me, and of course governments don't apologize to scientists, and an editorial in Nature recommending that this example of science advocacy in the oil sands should be copied for other issues. But as a result, we have a new wave. We now have this group in Ottawa who've declared that radical groups are derailing our economy. And they fingered groups like Greenpeace and so forth. And I'm sure they lump environmental scientists right down there as among the wild-eyed green groups. I think the Rick Mercer show with its PMO pest control skit has it right. They'd really like to silence all scientists by spraying green gunk in their faces when they have something that isn't in line with their economic agenda. We can't make science policy in a science vacuum, sound policy. We really need to have the science on the table, not the fictional science that comes from the mouth of the soothsayers that are hired by politicians, but real science. To me, it's a fundamental of how an informed democracy has to operate. And of course, we have this going on. We're getting less science produced. We're in the midst of cutting the people who do the work in all of the science departments. See no move to eliminate soothsayers or real bureaucrats. And of course, we have a culture there that looks something like this, which is why on the news today, you find that public servants aren't going to work. They get up in the morning and they feel sick, so they don't go in. So we really have a government that is keeping us away from the real big picture. And this is not lost on Europeans. This is taken from Nature already 4 years ago, talking about scientists as advocates in Canada and the good research programs, but the fact that instead of putting these in a position of prominence as they did 30 years ago, the government is now downplaying them. So I think this cartoon pretty well displays our policy as we can expect it from enforcement of the Fisheries Act after Bill C-38. This is from yesterday's paper. Michael Harris, a well-known political commentator who's not a scientist. Even I cringe when you talk about governments actually lying, but in fact, this is what they're doing to people. And we have to give them a clear message as a society that we're not going to stand for this. I'm going to finish with just leaving this slide up here. This is advice for particularly young scientists, why we urgently need more science advocacy. This is all of the problems we have that are on the table right now. And we need some incentives for science to communicate. We don't get these in ivory towers. We need to unmuzzle our civil servants and to get scientists back instead of bureaucrats. And ministers should be culturing scientists to underpin their policies, not ignoring or even denying them. But we could have some communications and things. I think the clear thing is, no matter how small your area of specialty is, try to keep track of the big picture, because it's the big picture that we really need as the basis for policy in the future. Thank you.
Hi, thanks for that invigorating talk. My name is James, and I'm from Winnipeg, and I am interested in the Lake Winnipeg issues. And given the interconnectedness of the water systems flowing into that river, not only across provincial lines, but international boundaries, as well as very drastic changes to the output of that river along the Nelson.
Right.
I wonder if you could comment on to what scope can issues like that be best addressed? Do you approach provincial governments or federal governments or international panels, or do you just kind of take a shotgun approach and try to blow holes across all of them?
Well, right now, as you know, the province has just come out with a policy recommending a 50% reduction in phosphorus. And that's the extent of it. although earlier they had been listening to people who wanted nitrogen reduced as well. Their position for the city of Winnipeg is still that they want Winnipeg to reduce nitrogen, which is totally crazy. I've looked over the engineering designs for those plants. They need to nitrify the ammonia output from those plants to avoid ammonia toxicity. They don't need to take the expensive step, which is to denitrify the nitrate after it's produced. So in that respect, I have to agree with the city of Winnipeg and not the province. There have also been some making cases that there'd be eutrophication problems downstream. Not the case. Lake Winnipeg as a fishery is very, very productive, and if anything, the fisheries downstream could benefit from a bit more nutrient. And you wouldn't even be able to detect the amount getting to Hudson's Bay. And I've heard claims that Hudson's Bay would become eutrophic, which is utter nonsense. So hopefully all of this will be put together. Right now, 65% roughly of the phosphorus input comes out of the Red River. It's been over time about equal US and Canadian as sources, though I've noticed the last 3 or 4 years the US contribution seems to be dwindling. And I don't know what's causing that, if it's regulation or some coincidence, but we need to get that whole basin under control and we'll have a good start on solving the problem.
Hi, my name is Matt Carroll. Thank you very much for a very inspiring talk. I think you're a real hero. I teach the only class in my program at Washington State University that tries to give the students the big picture, and I have a lot of biophysical oriented students as well as some social science students. But one of the things I tell them is that some of them tend to assume the opposite side of the problem than you've presented today. Some of them tend to assume that their science leads directly to an obvious policy, and they're not aware that there's always a translation process between a scientific result, which is just an estimation of cause and effect, right, ultimately, and what the society should do about it. And it seems to me that one of the challenges that future scientists have is understanding that there is inherently a translation process, and that translation process is not going to just be done by them. And if they ruin their image as objective scientists, if they're seen as advocates in the sense of, not in the sense that you use it, but in the sense of having an agenda to begin with, a political agenda to begin with, that they actually hurt themselves in terms of their effectiveness as change agents.
I would say that's right on, and this is the reason that Naomi and I co-taught this interdisciplinary course where we try to get half social science and half natural science graduate students. I think I would, the best I would claim is that there ought to be good science on the table. It ought to be part of what's there to make the decision. There are going to be decisions made that to fly in the face of good science. I'd like to see a good monitoring program for the oil sands. I'm not so sure that that would make any difference to our public choice, and I'd probably just have to, in a democracy, grit my teeth and live with the fact that we're going to threaten a bunch of natural ecosystems and native peoples. But that's the nature of democracy. But denying that you need any science or falsifying the science is not the way to get there. I also would say that scientists ought to be able to go beyond their data. I think what they ought to do, though, is indicate where they have data and where they start to rely on intuition. And again, I would tell people that if I'm looking for a solution to a strange plumbing problem and I can't get anyone to visit, I can only get advice by phone. If I have 3 advisors, a politician, a priest, and a plumber, I'm probably going to phone the plumber.
Thank you very much, Dr. Schindler. Emily Huddart Kennedy and I work here at the university as well. I wonder if you could speak a little bit, since our audience is international, to the ELA and the place it is in politically right now.
Sorry, could you repeat that, Naomi?
The Experimental Lakes area.
I'm a little bit hard of hearing. So.
Oh, the Experimental Lakes area. Is that audible? If you
Yes.
could speak to our audience about what's happening with that right now politically.
Sure. As part of their move to downplay environmental science, the federal government is threatening to close or sell the Experimental Lakes area. And they've come up with the usual arguments that are complete nonsense. The first was that the program was no longer producing. The reason it hasn't been heard from publicly is not because it hasn't been producing. The number of papers and the number of policy relevant papers has been constant over the years. The reason it isn't publicly known is because they've muzzled the scientists. So we've now made that clear. So they've changed their story. It's now that we have to move the science west because we have problems in the oil sands and so on. But Minister Kent assured me personally last February that they didn't need to close any of their other programs, that industry would be paying most of the shot for the oil sands. So overall, it just looks like they don't like programs that produce inconvenient data that they might have to consider in addition to just sheer economics. This closure, though, is being met with huge resistance. At this point, they have letters from almost all of the first world limnological societies. They have a public petition with over 12,000 signatures, including Paul Martin and 2 provincial premiers before them, and 2 former ministers of fisheries. And a lot of eminent scientists have written letters on their own. There's a proposal by As It Happens that the minister and I debate this in the next couple of nights. My guess is the minister will not respond, but we'll see. They probably will close it anyhow, but they're going to get a good black eye if they do. I think the way they could keep it open would be to open it up to U.S. universities as well. Cost is too high for the sort of 2-bit budgets that NSERC and SHRC give to Canadian universities, university professors. And most of them already have field stations of their own, though not with the broad mandates. The cost would be a good deal for a typical American field station. There's a good reason why there's no trouble getting research money from the National Science Foundation via U.S. Contributors at the Experimental Lakes. So if they'll take that step, I frankly would like to see this out from under fisheries and oceans. While the budget, the continued budget, meager as it is really useful for long-term monitoring programs that are necessary to run the experiments. They don't know how to manage people. They manage people the way old-time dog drivers used to run their dogs, by whipping them. Modern dog drivers get good performance from their teams by encouraging them. And it's time these business so-called leaders learned how to do that.